Hello, my dear students. Once again, we are here in the same platform, and in this platform, we will discuss about one more very interesting and important topic of chemical kinetics chapter, that is integrated rate equation of first order. In our previous lecture, we discussed about integrated rate equation for zero order reaction. Now we will talk about first order reaction. So first of all, key points about first order reaction. And first order kinetics or first order reaction means in this class of reaction the rate of reaction is directly proportional to or equal to first power of the concentration of reactant. This is rate law for reaction in which A is converting into product, A is reactant. Now for this rate law I can write like R equal to K A to the power 1, and this 1 denotes this is first order kinetics, correct? So for this, from rate law, R equal to K A to the power 1, A is nothing but reactant concentration. Students, don't focus on product concentration only. Here the very much important is reactant concentration, correct? And rate of disappearance of reactant, so it is minus sign with respect to time, that is d by dt, concentration of A, and negative sign means concentration of reactant is decreasing as time proceeding, right? So further it will be minus dA upon dt equal to Ka, or further I can write minus dA upon A equal to kdt. This is nothing but this is differential rate equation. Somehow examiner can ask for any kind of reaction, write differential rate equation. In NCERT book you will also see the same problem in your exercise, that in that side he is asking differential rate of reaction for particular reaction. So in similar manner you can design the differential rate equation. After integration of this differential equation, I will get log E concentration of A equal to minus Kt plus I, and I is integration constant. How it is? See here. We know integration of dx upon x equal to log base Ex or ln x, and integration of dx equal to x, correct? So this term will equal to log E base A, because it is nothing but dx upon x, and further dt, integration of dt is equal to t, and the constant is outside here, k is rate constant, so that minus k will remain as it is, minus k into t, because one constant is already here and it is named as rate constant, so that further one integration constant will be introduced here, okay? So I is nothing but it is integration constant or integrated constant, correct? Now we are here at the stage where further we can move for integrated rate equation, because we just solved differential rate equation. Let t equal to 0 means reaction is not started, or we can say the concentration of reactant is not consuming, not decreasing, correct? So if t equal to 0, the concentration of A at any time t, it will become initial concentration, nothing but initial concentration, means when reaction is not started, the concentration is about initial concentration. So on putting the above value on equation 3, we will get log base E A naught equal to I, or here I will equal to log E A naught, because this term become 0, right? So from equation 3 and 4 I will get log E base A minus Kt plus log base E A naught. A naught is what? Initial concentration of reactant, and A is concentration of reactant at certain time, at particular time. So I can compare this equation with a straight line equation, that is y equal to mx plus c, and this straight line equation is very much helpful for plotting graph. So on y axis it will be concentration with log, and for x axis it will be time. So in chemical kinetics I already told you in zero order reaction that in chemical kinetics we used to plot graph between log E A, means, or it is concentration of A versus T. For zero order reaction it was A versus T, and for first order reaction it is log A versus T, correct? Because I took log E. So it is log E versus t. So on y-axis it will be log E A, on x-axis it will be t, and this term minus k is nothing but this is slope, and this whole term will be what? This whole term will be intercept. So slope equal to m equal to minus k and intercept c equal to log E A naught. Students, sometime examiner can ask about log base 10. So there's one formula in which by using this we can convert log base e into log base 10 by simply multiplying 2.303 with log 10. So it will equal to log base e, means the log base e is equal to log base 10 when we will multiply the term 2.303. So graph will be similar. Here log base 10a upon versus t. Intercept will be log base 10 a naught, same thing. E in place of e I can use, or we can use 10, but slope will be different because I have to multiply this term 2.303. So by arranging this equation, slope will be minus k upon 2.303. So the equation is very important, and this year in 2020 examiner already asked about this question. The graph is already asked in your CBSE board exam in 2020. Ki this graph belongs to which order? So we have to write it is 0 order. What is the value of slope? Slope is nothing but minus k upon 2.303 when graph is between log 10a versus t, and slope equal to minus k when graph is between log EA versus t. And in 2019 it was graph for 0 order reaction, correct? So in consecutive 2 years he asked graph for 0 order and first order, so it can be repeat again and again. So now using equation number 5, on rearranging this I can found one more equation, that is k equal to 1 upon t log E base a naught upon a, or it will be log 10, then I have to multiply by 2.303. This is final equation, and I will use for this equation for my numerical solving approach, correct? So k equal to 2.303 upon t log 10 a naught upon a. It is nothing but it is final integrated rate equation for which order? For first order, students, correct? So no need to learn a whole derivation, just simply go for differential rate equation, and then this graph plotting equation y equal to mx plus c, then further graph, and then next is final integrated rate equation, correct? So by using these 4 to 5 parameter, you will be strong in your chemical kinetics, and the concept is first order reaction. So you have to need what? That graph equation, that differential rate equation, that integrated rate equation, that is what? K equal to 2.303 upon t log base 10 a naught upon a. Students, here a naught equal to initial concentration and a equal to concentration after consuming the reaction. Suppose examiner is saying that the reaction is 20% complete or 20% consumed. So here a is 100% and a is 100 minus 20, answer will be 80. Something in this manner we can solve our numerical problem. Now this time to discuss half-life period. Already we discussed in zero order reaction. In the case of zero order reaction, half-life period is T 50% or T half, and it is the time in which the concentration of reactant is reduced to half of its initial value, initial concentration. So suppose T is exactly T half, then A will equal to A naught by T. Matlab what? Suppose I have to travel 0 to 5 kilometer. So 2.5 kilometer is that time where I will cover half of the distance. So same example I can put here, we can use in this scenario. So that T half equal to, on putting this T half and A naught upon T in equation number 6, so I will get T half equal to 2.303 by K log 10 A naught upon A naught by 2. So it will be log 2, and log 2 is nothing but 0.3010, correct? So T half equal to, after multiplying this, I will get 0.693 by K. This is final हाफ लाइफ इक्वेशन फॉर विच ऑर्डर, फॉर फर्स्ट ऑर्डर, ठीक है. तो नाउ हियर one thing is very much clear, that T half do not depends on A naught. And what is A naught? A naught is what? A naught is initial concentration of reactant, remember. But in the case of zero order, when we derived the equation for half life period, it was about T half equal to A naught upon 2k, and in that case T half of zero order is directly proportional to initial concentration of reactant. But here there is no such thing like this. T half is independent to the initial concentration of reactant. So students, in our next video lecture we will solve some numerical based on zero order, first order, and this concept is very much important, or you must be clear that what thing you have to learn. Number one, differential rate equation. Number two, that y mx plus c equation. Number three, that graph between log e a versus t and log 10 e, a versus t. Next is integrated rate equation, and last one is half life period of first order reaction. So this is enough. This is done from my side, and this is enough to that you have to learn till here only, okay, not the complete derivation. He will not ask that you have to derive the complete whole derivation for your board, right? So if you will learn this thing, it is enough, it is strong, so that you can build up your concept at a high level. So till then, thank you, thanks a lot.